Hi, Brenn. Thank you so much joining the Tech Talk on a Sunday evening. Appreciate. Why don't you just introduce yourself and take it from here?
Sure. So I'm Brenn Hill. I'm the head of engineering at Zalopay, part of VNG here in Vietnam. Got about, I think we're up to about 70 engineers under me as my two divisions. So I handle promotions and our core financial platform. So yeah.
Cool. So, do you want to take the conversation forward? Because you were like interested to talk about this designing highly available infrastructure.
Yeah. So I
What
didn't
is
know
it
if you
actually? What
introduced
is this
the
highly
topic.
available infrastructure?
Yeah, so I mean, my background before VNG, I did a lot of consulting, worked at a couple of startups, financial startups, e-commerce, things like that. And so any conversation I have about high availability, I actually like to prefer to start somewhere other than tech because when I was in consulting, there was this really sad for them, hilarious for me event where we had a client who needed high availability, and we came in to build an application, but we were looking at their infra, and we were like, this isn't really robust. And they're like, no, we got it. It's okay. You don't need to mess with any of that because, of course, they just think we want to bill hours. We're just like, all right, you do what you need to do. And then, of course, like a year or two later, we've moved on, and we get this frantic call from them that stuff had crashed, and they hadn't checked their backups. They hadn't built redundant. They had never checked any of the things that were supposed to fail over actually failed over properly. None of that stuff worked. So, uh, my first intro to high availability is paranoia. That if you really want a highly available system, you need to be paranoid about all the things that can go wrong and will destroy your availability. And the more paranoid you are, the better. I mean, if you're like one of those crazy people with dots on a board, maybe that's too much. But like a couple steps back from that, it's probably okay. Um, and then it's just like a budget, right? Like, again, it's like how much are you willing to invest? How much is that availability worth to you? And then you're having a real conversation. If we just jump into like let's make everything, be forever, then that can also be ridiculously expensive. But if you start being paranoid and start really judging your risks and then say, well, how much is this risk worth? What is the cost of this going down and what's the, likelihood of it going down? You multiply that percentage times the cost, you get a number. How much does it cost to fix it, right? Um, Shockingly few organizations really have a cold, rational conversation about that. Really good organizations do, but not all of them. And at least out here in Vietnam, you have a lot of startups that at the beginning they don't care. They just want to hit product market fit, go to the moon, and then they have to be available, right? Like now they have customers, and they haven't found that moment in time, that break to really look into it. So once you have that conversation and know what your risks are, then you're looking at the tech. And for me, like just for people who are maybe watching this in the future, there's like a couple of obvious things that can go wrong. Um, One is what I would call the happy failure is you get so much customer traffic that you're overwhelmed, right? That's the good way of having availability issues.
Champagne
Um,
problem.
yeah, like that's like a high quality problem, as I like to call it. Wow, we have so many customers, we're overwhelmed. But then most of the rest are not so happy. So one of them is the small one is component failure, where like one piece of hardware, some critical piece of hardware, fails. And a lot of startups now are in the cloud, but still in Vietnam, there's a shocking number that are running on physical hardware or what I would call like fake cloud. Like there's a lot of providers out there where I can call them up and I can say I need some servers and they'll give me some servers and they may be containerized or whatever, but like it's all in one data center. It may all be in one physical rack. And if the power supply in that rack goes down, it doesn't matter that you've got Kubernetes and containers. You think you have all this robustness, that whole rack dies, and you're not, and it's not even your rack. Like, so you're just calling these people frantically, being like, "What do I do?" And there's not much. You wait for them to fix it. So People don't always think that through. They think, oh, I put it in the cloud because I hired somebody, but that doesn't actually mean it won't suffer a hardware failure and die. That's one of the things that actually happened to a client years ago, and that caused this thing is that they hadn't tested their backups, but what happened is the main servers that ran thing, that whole rack died. They had physical servers, and they thought that all these redundant servers, like if one machine in the rack died, it would be okay, but the whole rack died. The power supply overloaded, and everything got fried, right? And then it was bad, right? Like, and I don't know how that happened. I just got like the really freaked out call. Um, so anyway, so there's that aspect to it, and then kind of going down the list, you can have deeper infra failures. So let's say you do use Amazon or Google. Um, Amazon has had entire regions go down, right? So and I like Cloudflare as like a web application firewall, DNS, edge cache, right? But they've had regions have issues go down, certain core services go down. So it doesn't really matter who you use as your cloud provider or whatever. You can have massive, parts of globe scouting out, size outages sometimes. And if your application has sufficient high availability needs, you have to deal with the fact that there's a small but not zero at all chance that like the entire east coast of North America could be down, like all at once, because that's happened. And it doesn't require something crazy like nuclear war breaking out. That can just happen because someone pushed a bad update to switches or something. Um, and so people often treat that like the chance is zero, but it's very, very much not. And then you also have what I would call change failure, which people can measure. So you push a code update, and that causes haywire, right? And a lot of times, talking about change failure, if people are used to like really agile teams, they're pushing changes all the time, and usually that's safe. The changes being a catastrophic failure go down. But um, I've seen that breed an unawareness of certain changes. So, like, you might have a change where you change like a data schema, and then everybody rolls forward maybe multiple services at the same time, and there's not a good fallback, right? And then when you try to roll one service back, it breaks everything else. So now you have this problem where all these other services are actually working correctly, but they depend on something upstream that broke, and then you have to try to roll back, and then it gets crazy, right? So and that's really tough, right? Because then you're having to think very carefully about like backwards compatible APIs, and if this API doesn't work, is there a fallback? And again, that's like, what's your error budget? What's your requirements? If you can be down for 30 minutes, if it's a photo sharing app and you're down for 30 minutes, you don't care. If you're banking or fintech like us, 30 minutes is really scary. So that's bad. So you have to really think through, and I'm going through exercises like that right now with like database upgrades. It's like how many, if this fails, if this fails, if this fails, like what are all our fallbacks and all the way, really being careful about it. Um, so then so those are all the failures, and it's like, well, how do you deal with it, right? How do you prep for all this and actually architect something? And I like to start with all the things that go wrong, because if you don't know the problem you're solving, well, I mean, you'll solve some problem. I don't know if you'll solve the right one, um, but you'll solve something, maybe. So what do you do? Well, I like to kind of do an exercise where I trace through the path of everything. And this is actually something I use sometimes to interview developers. Like I'll say like, okay, from the time you hit like enter trying to access a website and like your URL bar and Google Chrome, what is everything that happens, right? Do they know that there's like an options request to get like a course? Like, do they know all the security pieces? How deep can they go in that chain? So what you want to do is actually go through the whole chain. And, if you're using cloud, right? Let's say you're on AWS, right? Well, you're going to hit probably, I think it's Route 53 is their distributed DNS, right? Like, okay, well, what happens if that has an outage or a partial outage? How does it route around things, right? And Google has a global DNS, and Amazon has their own like kind of global DNS, but it's not quite the same. They actually don't work the same. And I don't remember the details offhand, but like they matter. They do not actually work exactly the same in terms of how they deal with failures. And then, behind that, you probably have like a load balancer, maybe possibly multiple load balancers, and like a regional thing where even if you get the same IP, right, you may go to a different bucket. So if one of those buckets fails, what is meant to detect that failure and what happens when it fails, right? Because it's first in the chain. There's like the load balancer, and then there's the thing behind it. So what happens when the load balancer fails? You haven't gotten to the application. What's your failover for the load balancer failing? What's your downtime? It might just have a health check. It might come back up, but like, how many minutes is it? How often will that happen? You want 99.999% reliability. You've got to add that up, right? This will fail approximately X percentage of the time, and it will cost us 5 minutes of downtime a year. But if your budget is 50 minutes of downtime a year, 5 minutes sounds like nothing. Like, wow, we're down 5 minutes in a year, and that 5 minutes might be 1 a.m. No one cares. No one even notices, but technically it's part of your budget, how long you can be down for some reliability. And then you're like, okay, now I'm at my application. And then that's where most developers are. And then you kind of have an interesting conversation to have with the developers, because what counts as downtime? So if I have, let's say, a service that itself calls a bunch of other microservices, and one of those services is down, but it can recover from that failure. Maybe I load my page and some little widget doesn't pop up. Does that count as a failure? Often, no. The user is almost certainly happy unless that widget's really critical, right? So that's actually one of those ways where if you're gonna have stuff fail, being able to like fail in a very graceful way, like that, like micro front ends or something, is great, right? Because this is something where you can be highly available by your metrics and by your perception by your users, but you can still have things break, you know, but it won't destroy you. Um, and you won't get panicked calls. There'll just be some widget that doesn't show up, and they'll be like, huh, I guess they updated their UI. I wonder why they did that. And then they'll come back the next day and like, oh, the widget's back. That's interesting. And they'll move on, right? Because as long as it's not a critical service, if you're logging into a bank and you can't see your balance, you're going to freak out. But, if you don't see a button for like call support, you probably don't care. So you probably don't notice. So it's okay. Um, so you haven't asked me any questions to kind of dive into this, but I go through that sequence where I literally like, you can draw a diagram of all your microservices and you're like, happens if this fails? How does it fail over? What if this group fails? What's the fallback? What do you do? And then you measure those out. Frequency, cost, right? You've got a budget, you've got how much time, right? For some SLA, and there you are. And then to design against those services, you are looking at things like distributed DNS. You're looking at a load balancer with Kubernetes, health checks, readiness checks, right? Failover, like fast failover, and you have to measure how long that failover takes. Because even if you have a recovery method, it's down for some percentage of people for a few minutes, right? While it figures out that the health check failed. And on down that stream. And then once you've done that, you're going to the more nasty things like scale outages. So I've worked on services when I worked in sports consulting. There was really no nice, pretty ramp up of traffic. So like I used to do stuff for NASCAR and PGA Tour and things like that, and that graph of traffic is like flat and then like a straight line up. And then as the game starts and then it kind of drifts down, right? As people get bored of the game or don't care anymore, their team is losing or whatever it is, right? So you'll have like 10 million people show up in a very short period when before there's like 1,000, 10,000, like nothing. And so how do you deal with load spikes, like massive load spikes? And what's your strategy for that? Um, a lot of times the strategy for dealing with really aggressive load spikes is some level of caching, if possible. Sometimes things are too personalized for that, but I don't know, 99% of the stuff that I've worked on, if you have load spikes that high, it's usually because there's some sort of mass market event that makes everyone do it. The exception may be something like if you had the stock market's crashing, everyone logs in to see their personal balance because they're freaking out and they want to sell everything. And that's tough, right? And even, even some of the best banks and organizations struggle with hyper personalized and ultra load spikes, because I've noticed, like, when, especially with the market melting down like the last couple of months, like I've noticed, I log into my app and they're like, we're experiencing technical difficulties because we're being slammed, right? Like everyone's freaking out because the market dropped 5% in a day, and so I don't know if you want to dive any more into that. I think we've gone not 20 minutes, but good piece of it.
It's really interesting, right? Because I really like to understand, like, for example, to do all those work and analytics, who are the roles that you work with? Because this thing cannot just come from architects, right?
No, no, it needs to be an entire organizational thing, right? So I can sit there as an architect and draw a bunch of boxes. I actually don't know how much that's going to fail. We're making it up, right? If you've got boxes and arrows, what you should be doing is, and most of the cloud services have things like what is it, CloudWatch and other things. They can give you statistics, and you can use Datadog and things like that. They'll tell you when you have an outage. You can see all your traffic. You can see, right? So you just want to wire it up to all those analytics services, and then your engineers, your DevOps especially, everybody needs to be part of this. So usually, like as an engineering manager, I'm going to look at this stuff every day. I'm just going to see how the services that are doing that are critical, see if anything weird happened, maybe get a report. But it's not one person. It's like you build this into your system. So if you want high availability, I can draw these boxes, but the engineers need to know how to wire it up, right? If I say we need to have Kubernetes and this failover and this, auto scaling group, for instance, in like AWS and auto scale groups, there's a bunch of ways to make those things scale, right? There's a whole bunch of settings where it can deal with number of requests, CPU load, RAM, right? What's the right setting? Well, you need to test that, right? There's actually quite a bit of what I would like of what is really technical QA, like failure prep QA, where you break stuff. And like Netflix does chaos engineering, where they actively, proactively are blowing stuff up. So that can sometimes be an entire team. I don't know if there's one magic way of organizing this inside of an organization. I've seen it where there's like a security group that does it. I've seen it where there's a DevOps group that does it. With my teams right now, we have the individual teams. Like I have one team that's doing really well, that's trying out chaos engineering and is planning to unleash Chaos Monkey. And they're not working with mission critical services. So if something goes horribly wrong, it's okay. Like, but I had to tell the CTO, like, hey, we're going to try this. And he's like, okay, just don't nuke the planet, right? When your monkey goes crazy. So, it's really a responsibility for everyone. The conversation that I'm more likely to have is like, how do you train those skills up? Because it's easy for me to say, hey, test everything and write some stuff on a board, and now you have your budget. But you only get the numbers from doing either some historical data, if you have it, or some experimentation, right? And I'm a big believer in proactive experimentation. So um, find a time where everyone's ready, like every given team, and turn one of your services off when you know it's like not super high traffic, right? You're not going to really piss people off. Turn it off and turn it back on again. What happens? How long does it take to come back up? Like you can just measure that with a stopwatch, right? You should be able to see it in some dashboard. You should see something go to zero, right? Come back. You got to test the dashboard. If the dashboard keeps showing you that everything's happy, dashboard broke. You're not paranoid enough. You think you got a dashboard, you're wrong, right? Um, but that team should hold it. So whoever is accountable, whatever team is accountable for that service, needs to have those dashboards, needs to be accountable for those net metrics, needs to test those metrics. And then I, as a leader, need to kind of make sure that they have tested it, right? I think the scariest part as a leader is you have so many teams. If they're constantly launching services, how do you know that they didn't make a bunch of changes and accidentally break the dashboard and the dashboard looks happy and it's not happy, right? It doesn't happen a lot, but I've seen it happen, you know. Um, so I'm hoping that answers your question. I mean, it really is like an organizational skill.
True. Actually, one of the things that I used to, a bit of a struggle also was getting product managers, right, on board on
Right.
this. What's your experience with that?
It depends on the product manager. I mean, some product and the company culture, right? So like you're coming from fintech. I've worked in fintech and I've worked in sports. And fintech, if something involving money goes wrong, people get really angry. And it's funny, sometimes product owners are more afraid of breaking things because people are going to get really angry, even though that's probably the place where it's most important to proactively break things so you know how to recover. On the other hand, like in sports, it was a little bit easier to break stuff, especially pre-go live, because there's a nice easy cutoff date. This is when the event's happening, and we can do whatever we want before then, because basically no one cares until the game starts or whatever. Easy, right? They're like, as long as you can schedule it 2 weeks before whatever, the Super Bowl, go nuts, fine. But not always. Um, so I think it really comes down to having a conversation with the product owner about risk and about the impact and about their own safety and sanity going forward. You know, um, One of the things that I have done and it scared me, I was working with a company and they had this Redis cache. And I asked the engineers, this was not a system that I designed. I said, what happens if this cache dies? And it was a replicated cache, it was quite robust. Like, what happens if this cache dies? I'm like, we don't know. I'm like, but it holds all this order information, right? And I'm like, yeah, okay. So like really important stuff. And it's like if this dies, no one really knows how it comes back up. Now, would the system recover? Probably, but would orders get lost? Would money get lost potentially? Oh, probably, maybe. We don't know, right? Not where you want to be. So you go to a product owner and you're like, hey, if this happens, these are the potential consequences, right? And we're gonna eat a week running around like chickens with our head cut off, trying desperately to deal with all these customer service issues, money issues, bank refunds, like all these problems, right? Or instead of having this foisted upon us at probably the worst possible moment, because when is that thing going to die? Well, probably under heavy load. Like, if this is like e-commerce or something, Christmas is when the cache is going to die. You're going to overload it at the worst possible moment. Something's going to blow up, and at the time you most want it not to fail, that's when it's going to fail, and you're going to spend the next couple of weeks dealing with that instead of having like really good metrics, right? And that's not where anyone wants to be. And they're like, okay, maybe it's working. Like maybe that would be bad. Yeah, probably, right? And there's a financial impact, right? So at, at some companies, depending on the exact service, you can actually calculate, like say checkout broken in e-commerce, right? If checkout's broken, how much money do you normally make per hour? Well, every hour you're losing that much money, straight up, right? And then probably more as people realize that it's broken and don't come back for a while. So you're going to lose some residual sales even after it's recovered. So you just have a number, right? And you're like, look, this probably won't happen, but if it does happen, it's worth $2 million. So can we please check that this doesn't break bad at a time when it's worth a lot less to do the test than $2 million, especially when you can do that testing usually in some like UAT or QA environment or something and measure like how long it takes to recover and what that recovery looks like and get some like get like a run book. Like if this happens, here's the instruction manual. Do this, do this, do this, do this, check these settings, right? Get that documented. Because the other thing that happens, and I've seen this happen, is when things break, it always likes to break at the worst possible moment. It's going to break under load when people are on vacation because it's like Christmas or something, and people are gone, and the person who knows the system is off duty, and no one knows what to do, and right? So, because those are the same organizations where you have the product owner who or product manager who's under a lot of pressure to ship, to constantly ship stuff all the time. That's why they're often resistant. And then, okay, who's going to do that? So, that been your experience?
Yeah, I mean, it happens, right? Because like what you mentioned, when the product owners they are not capable of owning P&L, and then they become a feature factory owners, right? So then, yeah, these kind of things become in the picture. Right? All right, cool, man. Bren, I mean, we are out of time. It was really amazing having a chat with you. I appreciate it.
Glad to
Is
have
there
me
anything else
on.
you want to wrap up, or that was it?
No, I really enjoyed the talk. Happy to talk again at some point. So,
Yeah,
hi, all
sure.
the
We will
people in
definitely
YouTube
arrange
land.
more sessions. I'm trying to usually keep these sessions less than 30 minutes or 25 minutes so that people can watch, so that they can understand what the topic and
I get it.
concept is, and they can Google it later. Right.
Yeah, yeah, yeah. I think the detailed stuff is better for written documents for sure. So
All right. Thank you, buddy. Take care. Have a good evening.
later.